Have you ever wondered how Google Bard really works? It's a question that's piqued the curiosity of many, especially those with an affinity for technology and innovation. Google Bard, an impressive feat of artificial intelligence, has been making waves in the tech world for its remarkable ability to generate text that is strikingly human-like in quality. Let's step back a bit and delve into what Google Bard actually is. At its core, it's a language model, a piece of software developed by Google that's designed to understand and generate text. But it's not just any language model. It's a product of cutting-edge technology and years of research, a testament to Google's commitment to pushing the boundaries of what's possible in the realm of artificial intelligence. Google Bard's purpose extends beyond just generating text. It's designed to mimic the intricacies of human language, to comprehend nuances, and to generate coherent, contextually appropriate responses. It's about creating an AI that doesn't just understand language, but can also use it in a way that's indistinguishable from a human. The true marvel of Google Bard lies in its ability to generate human-like text. As you interact with it, you'll find yourself forgetting that you're conversing with a machine. It's able to craft sentences that are not only grammatically correct, but also contextually relevant and nuanced. It understands subtleties, grasps sarcasm, and even exhibits a sense of humor. It's like interacting with a well-read, witty human being, except it's not a person, it's a product of artificial intelligence. So, what is it that enables Google Bard to create such realistic text? What makes it so adept at mimicking human language? What sets it apart from other language models? To understand that, we'll have to peel back the layers and delve into the world of machine learning, neural networks, and training algorithms. So you might ask, what makes Google Bard capable of creating such realistic text? Well, stay tuned as we unravel the mysteries of Google Bard in the next part of this series. The secret lies in machine learning, the engine that drives Google Bard. Now, this might sound like a line straight out of a sci-fi novel, but it's actually quite rooted in reality. Machine learning, in simplest terms, is a way for computers to learn and make decisions without being explicitly programmed to do so. Picture a child learning to recognize a dog. No one provides a precise blueprint of what a dog looks like. Instead, the child learns from seeing different dogs in different sizes, breeds, and colors. Machine learning is quite similar. It learns from data, recognizing patterns and making decisions. Now, how does this relate to Google Bard? Google Bard uses machine learning to comprehend and generate text. It's like teaching a computer to write a novel or a poem or even a research paper. It's not merely about stringing words together. Google Bard must understand context, sentiment, and even the subtleties of language, such as sarcasm and humor. To achieve this, Google Bard utilizes a specific type of machine learning called neural networks. Neural networks are designed to mimic the human brain, with layers of interconnected nodes, or neurons, working together to process information and make decisions. Just as our brains use neural pathways to understand language and produce speech, Google Bard's neural networks sift through enormous amounts of text data, learning to recognize patterns and generate coherent, contextually appropriate text. But it's not just about recognizing patterns. Google Bard also needs to understand context. Let's say you ask Google Bard to continue a story about a dragon. It needs to understand what a dragon is, how it behaves, and what might logically happen next in the story. This is where the magic of machine learning comes in. By analyzing countless stories about dragons, Google Bard learns to generate a suitable continuation for your story. So, how does Google Bard apply machine learning to understand and generate text? Well, stay tuned. We're just getting started on this fascinating journey. Google Bard utilizes something called a transformer neural network. Now, you might be wondering, what in the world is a transformer neural network? Let's break it down. It's a type of machine learning model that's designed to handle sequential data, like language, for tasks that require an understanding of context. Picture it this way. Imagine you're reading a sentence. You don't just read each word in isolation, right? You understand the meaning of the whole sentence, taking into account the sequence of words. That's essentially what a transformer neural network does. It's designed to understand the context of a sequence of words, not just individual words in isolation. The transformer model has two main components, the encoder and the decoder. The encoder reads and understands the input data, while the decoder generates the output. In the case of Google Bard, the input would be a sequence of words, and the output would be a coherent, contextually appropriate continuation of that sequence. The real secret sauce of the transformer model is something called attention mechanisms. These allow the model to focus on different parts of the input sequence when generating each word in the output sequence. This is how Google Bard can generate text that feels so natural and contextually relevant. Imagine reading a book and being able to recall not just the last sentence you read, but also relevant information from several pages back. That's the kind of contextual understanding we're talking about. So, the transformer neural network is a powerful tool for understanding and generating language. It's what enables Google Bard to understand the context and generate text that feels human-like. But remember, the transformer model is just a tool. On its own, it doesn't know anything about language. It's like a very sophisticated typewriter that needs someone to press the keys. And that's where training comes in. The model needs to learn the patterns and structures of language. It needs to learn how words and ideas flow together to create meaning. But that's not all. Google Bard also needs to be trained to generate human-like text. Training is a critical part in making Google Bard as effective as it is. Google Bard's proficiency in understanding and generating human-like text is no accident. It's a result of relentless training, much like an athlete preparing for a big competition. But instead of physical exertion, Google Bard's conditioning is purely intellectual, involving the digestion and interpretation of an enormous amount of text data. Imagine you're learning a new language. You start with the basics, then gradually move on to more complex structures, idioms, and nuances. Similarly, Google Bard begins its training with the fundamentals of language, learning from the smallest building blocks, words and their meanings. The corpus of text data used for training Google Bard is truly staggering. We're talking about billions upon billions of words, sourced from a wide variety of texts, including books, articles, and websites. This vast range ensures that Google Bard is exposed to diverse language use, styles, and contexts. But feeding Google Bard with data isn't enough. The real magic happens when it starts learning from this data. Google Bard doesn't just memorize words and sentences. It learns to understand context and relationships between words, phrases, and sentences. It's this understanding that allows it to generate natural, coherent, and contextually relevant text. Google Bard's training also involves a feedback loop. It's constantly tested and evaluated, and the results of these tests are used to refine its understanding and generation of text. It's a cyclical process of learning, testing, refining, and learning again. In essence, Google Bard's training is an iterative process of learning and improving. It's like a never-ending journey of language discovery, where each step brings it closer to understanding and replicating human-like text. Now that we understand how Google Bard is trained, let's dive into how it generates text. Generating human-like text is where Google Bard truly shines. This is where all the magic we've discussed so far comes to life. But how does it really do it? Let's dive in. The first step in text generation with Google Bard involves using the knowledge it gained from training. Remember the massive amounts of text it consumed during training? That's the knowledge base it draws upon. It has learned the patterns, the structures, and the intricacies of the human language, and it uses this understanding to generate new text. Let's simplify this with an example. Imagine you're writing a sentence and you've got as far as, "I'd like a cup of." Now, you and I, with our understanding of language and context, can predict that a reasonable next word might be tea or coffee. Google Bard does something similar, but on a much larger scale. The process is probabilistic. Google Bard doesn't just pick the most common word to follow a given phrase. Instead, it calculates the probabilities of all potential next words and chooses one based on those probabilities. This ensures variety in its output, and it's why you won't see Google Bard churning out the same sentences over and over again. But it's not just about stringing together words. Google Bard also pays attention to context and meaning. It understands that the words "I love you" carry a different weight than "I see you." It understands humor, sarcasm, and even poetry. And it uses this understanding to generate text that is not only grammatically correct, but also meaningful and impactful. To wrap it all up, Google Bard is truly an amalgamation of machine learning, neural networks, and training. It uses the knowledge it has gained from consuming vast amounts of text to generate human-like text, while the probabilistic nature of its decision-making process ensures variety. It's a testament to the power of artificial intelligence and its potential to revolutionize how we create and consume content. So that's how Google Bard works, a fusion of machine learning, neural networks, and training to generate human-like text.